this lecture, we will understand how a supply air terminal receives conditioned air through a duct, then distributes it into a room so that comfort conditions are achieved in the occupied zone. A wide variety of terminal equipment is available in the market, and therefore it is out of question for us to explore all of these in a short lecture. A grill is simply a cover for a duct. A grill has a rectangular face and a rectangular neck. It has louvers for deflecting the air coming in from a duct. The louvers may be fixed or their angles may be adjustable. A grill can be used either for supply air or for return air. Remember that a return air terminal must be located sufficiently distant from a supply air terminal so that it does not short circuit the supply air. A register is a grill equipped with a volume control damper. A diffuser is a more complex device. It enables air to be discharged in a spreading pattern in a specific path or in a particular direction. Shown on this slide is a supply air grill with horizontal and vertical vanes. Such grills are typically wall mounted slightly above the occupied zone. Shown on this slide are two types of diffusers, one of them circular and the other square. These are typically roof mounted. Shown on this slide is conditioned air being fed into a room via a square diffuser. Primary air or supply air is the air discharged by the diffuser and is shown in blue. Primary air is typically between 50 and 60 degrees Fahrenheit and is moving with high velocity and high turbulence. This causes induction, that is a mixing of supply air with the room air below. Total air is the mixture of primary air and entrained room air. The difference between the total air and room air creates a buoyancy effect causing cold supply air to drop and warmer room air to rise. The higher the supply air velocity, the noisier it gets inside the room. In view of this, the recommended maximum supply air velocities for different applications are shown on this slide. Throw is the distance from the center of the diffuser's face to a point where the velocity of the air jet is reduced to typically 50 feet per minute, measured 1.8 meters above floor level. Drop is the distance from the diffuser to the bottom of the jet, again where the air velocity is down to 50 feet per minute. Finally, spread is the divergence of the stream in a horizontal or vertical plane. Notice that the throw and the horizontal spread are indicative of the area of the room over which the supply air from the particular diffuser is getting distributed. Coanda effect is the phenomenon by which an air jet attaches itself to a nearby surface. The Coanda effect tends to reduce the drop and increase the throw. The higher velocity supply air draws in the room air and mixes with it, a phenomenon called air entrainment. The consequential expected temperature profile is shown on this slide. In the next lecture, we will take you through the process of terminal selection for a given application. Thanks for watching.